Hi, let's take a look at the law of cosines. Law of cosines is a relationship that exists in any triangle. And so what it tells us is if we have three sides of a triangle and an angle that we're looking at, that the relationship exists that if we square c, that's going to equal a squared plus b squared minus 2 times a times b times the cosine of c. So it's important to notice that we've got three sides and then we've got an angle, and that angle, this angle is the angle that is across from this side, and it's the angle that's in between these two sides. So let's take a look at what that looks like with numbers. So with numbers, if we had this triangle here and we put it into the equation, we can see that we get c squared, which is 6 squared, and if we calculate the right side of the equation, we get that they're both equal to 36. So now we're going to use just this one equation, c squared equals a squared plus b squared minus 2ab cosine c. Now there are some lessons on this that say, well, that's for c, but what about for a and b? And then they introduce additional equations for a and b. And then they say, well, what if we want to know, rather than c squared, what if we want to know c right away? So they take those and then they solve for a, b, and c by taking the square root. So you've got three more equations. And then they say, well, what if we want to know the angle? So then they solve for the angle in each of these, and they get three more equations. We are not going to use all 9 of these equations. We are just going to use this one equation and be able to use it for any situation. As long as we think about what needs to be a, b, and c in each of these situations, then we can just use the one equation and make it much simpler. So when do we use the law of cosines? Well, first of all, we use the law of cosine for non-right triangles. If we had right triangles, we'd use just regular trig functions or Pythagorean theorem to solve for missing sides and missing angles. So it's for non-right triangles. And then let's take a look at the equation. The equation, we've got three sides and an included angle. So in order to solve for one of those, we have to have three of those pieces of information. So either we have to have two sides and an included angle, or we need to have three sides. If we have any of those situations, then we can use law of cosines to solve for the missing piece of information. Let's take a look at some examples of how we could do that. For this problem, we're given two sides and an included angle, and we're trying to find the other side. So it does make sense to use the law of cosines. So what are we going to use for a, b, and c? Well, c is always the included angle. So we're going to use this as c. The side c is going to be the side across from that angle. And a and b, I'm going to assign a here and b here, but if you look at the equation, if you flipped around a and b, it really wouldn't matter. This would evaluate to the same thing if you switched a and b. So that you can just pick the other two as a and b. So now let's put these values into this equation. C is our unknown, so x squared equals a squared plus b squared minus 2a c cosine of the angle c. So all we did here was take all the values, put it into there, and now we just have to evaluate for x. So x squared is going to equal 15 squared is 225, 6 squared is 36, 2 times 15 times 6 gets us 180. Combine 225 and 36, and we get 261. Now punch in cosine of 40 into a calculator and you get 0.766. So x squared is going to be 261 minus 180 times 0.766. 180 times 0.766 gets us 137.8 888. Subtract those two, and we get 123.11. So now to get x, we just got to take the square root of both sides, because x squared equals 123.11. So if we take the square root of both sides, x could equal the square root of 123.11, or 11.1. In this problem, we have three sides, and we're trying to find one of the angles. So it also makes sense to use law of cosines here. So what are we going to use for A, B, and C? Well, the angle C we start with is always the included angle. Opposite that is going to be side C. And again, we can pick either for A and B, because the equation, you can interchange A and B and get the same thing. So now let's put all these values into the equation. We get C squared equals A squared plus B squared minus 2AC cosine, and now the angles are unknown, so we're going to take cosine of the unknown angle. All right, so now let's do some math. 8 squared is 64, 7 squared is 49, 11 squared is 121, 2 times 7 times 11 gets us 154. Combine the 49 and the 121, we get 170. Subtract 170 from both sides. 64 minus 170 gets us negative 106. Now to get cosine x by itself, we're going to divide by 154. So cosine of x equals negative 106 divided by negative 154. Put that into a calculator, and we get the cosine of x equals 0.68831. But we're not trying to find the cosine of x, we're trying to find the value of x itself. So if we have the cosine and we're trying to find the angle, we can use the inverse cosine. So we take the inverse cosine of 68331, we get an angle of 46.5 degrees. Thanks for watching. If you haven't subscribed yet, you can do so right over there. And if you like what you see and you want to watch more, I've got another suggestion for you right over here. Thanks for watching.